Next up, we're going to solve equations with rational coefficients, but this time the rational numbers we're going to focus on are decimals. Now, these next two checklists are just for review. You do not have to write any of this down. Just go through it with me. So a quick reminder of the steps that we want to follow. We simplify each side first. Remember to isolate the variable. That's our main goal. If you know the goal, it's much easier to get there if you know where you're trying to head. Then we undo addition if possible, and undo multiplication if possible. A couple other things to remind you of. These coefficients can be decimals, like what we'll see today, fractions, like what you saw yesterday, or integers, which are what you'll commonly see. Nothing is going to change with the way that we solve these equations. There's no new method. Nothing different is happening. It's just now that we have decimals. And we do need to follow our multiplying and dividing fraction and decimal rules. All right, so we're just going to head straight into examples. The best way to start this is to just jump in and go. So our first example, solve for x. 11.5 equals 2x. So the only difference between this and what you're used to seeing is that there's a decimal. But that doesn't mean you have to handle this any differently. Okay, we can still go through our steps. Is there anything to simplify? I don't want to simplify anything. Remember, our goal is to get the variable isolated or by itself, which means my goal is to have just x. I need to get rid of this 2. Now remember, these numbers, when we get rid of these numbers, if it's a coefficient, I need that to become 1. Because if that 2 can become a 1, 1x is just x. So that's part of remembering the goal, is if I need x by itself, that number that's with my x, what does that have to become? In this case, it has to become a 1 because it's a coefficient, because it's being multiplied. In order to make that a 1, I need to undo the multiplication. Okay, there's no addition to undo, so we're to the undo a multiplication step. Now remember, a number times its reciprocal equals 1. So some of you may need to look at 2 as 2 over 1 because the reciprocal is 1 over 2. So now I'm going to multiply each side by 1 over 2. The one thing to be very careful of, especially now that we're working with decimals, is make sure that your multiplication symbol doesn't get confused for a decimal. So don't use an x because we already have x's for our variables. You'll just need to make sure that that operator symbol is nice and large. So now when we multiply, I know it feels a little weird that we have decimals here, but just go with this with me. I'm going to multiply just like normal, as if 11.5 was not a decimal. We're going to multiply across, and I get 11.5 over 2. Now remember that a fraction is just a division problem. That's all it is. Something I saw the other day said, numbers in a fraction, if you change the numbers to dots, it looks like a division symbol, which is kind of cool. I'd never heard that before or seen it. So think about it like that. If I turned my numbers into dots, I'd have a division symbol. Pretty cool. So keep that in mind. All this is division. So take a calculator. Take a calculator, and in that calculator, you're going to type 11.5 divided by 2. I also want you, in your notes, to make a little side note of the order. Because what's going to happen is you're going to do all this algebra work correctly, and then you're going to type it into the calculator wrong and get the wrong answer. So take a minute, write a little side note that shows you what order to put it in the calculator. So type 11.5 divide by 2. and you should get x equals 5. Now, I haven't been having you check your answers, but if you're a little bit worried that you're maybe not, and you know what, that's not correct. Hold on. If you feel like maybe you're not doing something correctly, oh, you know what, hold on. Sorry, the key I have does not match the problem. So what just happened is when I was talking about checking your answer, I looked up into my equation and I said, if that x is 5, it would equal 10. It would not equal 11.5. So that's a clue to me that something is wrong with my answer. So again, when I wrote down 5, I looked back at the question or the equation and said, something's not right. That's what should be happening for you. The minute you make an error, you can figure out if you made it or not because you can check your answer. So even though I'm not doing it on the examples, truly you should be doing that on your own. At this point, it's one of those things that now you have to make the kind of grown-up decision to say, am I going to check myself or not? Do I want to make sure I'm turning in correct answers or not? That's kind of on you. My actual answer is 5.75. And if I substituted that, it would check out. So if I did check it, it would be 11.5. Is it equal to 2 times 5.75? Take my calculator, multiply it out. I do get 11.5, so we're good. Next example. X over 5 equals negative 1/100. Again, we have a decimal. Don't let that make you nervous. We go through our steps. Simplify. Nothing I want to simplify right now. Remember our goal. Our goal is to have x by itself. And then again, think about what do I need that 5 to become to keep x? And let's talk again. Our number either becomes 0 or it becomes 1. If you're not sure which number it's supposed to become, check it out. Well, is 5 supposed to become 0? X divided by 0. That's either going to be 0 or not possible. So that's not the number I need it to become. What about a 1? X divided by 1. X divided by 1 is x. So I know the goal is to make that 5 become 1 so that my variable becomes isolated. Okay. So again, knowing your end goal will help you figure out the best way to get there. So in order to get x by itself, one option you have, especially when you have this number in the denominator, even if you don't have to do this, even if you know exactly what you would do, take a second and do this for me, or do this with me, just so that you have another process, as an extra step of work that may come in handy to you at some point. But if I need to see, if you look at this and say, I don't really know what reciprocal do I use? Well, there's always a 1 in front of the x. So I could actually take this little fraction and pull it out to the side. So I'm just rewriting this as 1 over 5 times x, because my coefficient that I can't see is a 1, and I have my 5 in the denominator. So if you do that, you can actually very clearly see that the reciprocal that I need to multiply is 5 over 1. My left side cancels. I'm left with x equals, multiply across, a negative times a positive is negative. 0.01 times 5 is 0.05. And that's a 0, not a 6, by the way. And that's my answer. Remember, with the negatives, it doesn't matter exactly, if you put the negative with the 0.01, with the negative with the 1, or the negative out front in the middle. the whole fraction is negative. Let's look at the next one. So negative 1.98 equals negative 2.2. Again, let's go through our process. I don't need to simplify. Remember, our goal is to get p by itself. I have a number multiplied by p. So there's no addition to undo, but there's multiplication to undo. We undo multiplication by multiplying by the reciprocal of that coefficient. So even though the negative is written with the 2.2, as long as I put my negative somewhere, I'm okay. I put it out front. The goal is, on this side, negative times negative is positive, and everything else cancels out, right? So that becomes positive 1p, right? Now, since I multiplied the right side by negative 1 over 2.2, I'm going to multiply the right side by negative 1 over 2.2. Now again, I have a negative times a negative, which becomes positive. And when I make these both fractions and multiply, I get positive 1.98 over 2.2. So again, don't let these positives and negatives get you stuck. Negative times a negative equals positive. That handles the sign. And then I just multiply across. Now, I just plug into my calculator. I plug 1.98 divided by 2.2. And I ran out of room, but 0.9 equals p. Now again, if you look at the process is exactly the same as if we were dealing with integers. It's just that there are decimals in the place, which means we'll use a calculator. No big deal. Let's look at another one. Solve for x. Again, no simplifying to do. Remember that I need n equals some number here. So this 2.5 is the problem. If you're looking for the fraction, because the reciprocal is what we're going to use here, because we're not having to undo addition, now we're undoing multiplication. So this 1 over 2.5 is what I need to eliminate. Okay, like example 2, if you want, to pull that 1 over 2.5 to the side as an extra step, if you want to do this, you can absolutely do this step. If not, from here, you can just look at this, put your 1 in, and then just go ahead and start using your reciprocal. So I'm going to multiply the left side by 2.5 over 1, because that will cancel and leave me with n. If I multiply 2.5 on the right side, or the left, I need to multiply it on the right. And 0.832 times 2.5 equals 2 8/8. So there really wasn't a lot of work to do here. You definitely want to show this step here, and then use your calculator and get your answer. Got 2 more. Next example here. Remember, go through our steps. Nothing to simplify. Don't forget your goal. M equals what? I need this is going to become 1. There is no addition to undo, so we go to the end, which is undoing the multiplication, which means this negative 1.5 over 1, I need to multiply by the reciprocal on both sides. Now on the left, my negative times negative is positive. My 1.5s cancel, and I'm left with m. On the right-hand side, if I multiply across, I have a negative times a negative, which makes positive. 6.6 over 1.5. Use your calculator, and m equals 4.4. So again, if you look at each of these examples, it's the same process. Even though things look a little different, we can find a way to keep the process the same, which is awesome. Last one. Again, let's go through our steps. Simplify. Nothing really to do. Remember our goal. P equals something. So that means this little guy needs to become a 1. Because P over 1 is just P. So there's no addition to undo, so turning 0.4 into 1 is an undoing multiplication process. If I look at this as the fraction 1 over 0.4 that I need to eliminate, I just need to multiply each side by the reciprocal. Again, making sure that you can tell the difference between decimals and multiplication symbols. My numbers on the left cancel, and I just have a P. On the right, I get 12 times 0.4, which becomes 4.8. And that's it.